Hello everyone and welcome to the Kubler Software channel. In this video we're going to take a look at a simple Earthworks volume estimating project that's a typical one you might see. This one uses PDF data, the PDF vector extraction process. If you do use CAD files, there's another video that you can check out for that one. So this is a simple project where we start with defining the site plans, extracting the existing data, then doing a phase for topsoil strip, and a phase for bulk earthworks, which consists of defining finish levels and then adjusting to subgrade. Okay, so let's get started. We'll have a quick look at the PDF file to begin with. It's always worth checking it out. So this one is got existing and proposed contours separated onto 2 pages. So we're going to have to use a process called stitching to stitch those site plans together. So I'll just close that one. So to add the PDF plans to begin with, we click Add Plans and then Add PDF File. So it's worth mentioning that we've got another version of this video where we're using CAD data. So if you want to check that one out, it's in the description below. So this one is for more people using the PDF process. So we select the PDF to begin with, and we've got page 1 selected there. Click OK. So the most important thing with PDF files is that they're scaled correctly. So we'll wait for it to load and then we can go through that. So when a PDF comes into the program, if it's a first page, it will be in paper space. So we do need to scale that. So there's a few different ways of scaling. You can scale by 2 points. So we actually have 2 geolocate points here, like one here and there. That's actually quite unusual. You can also scale by a length. For instance, there's the scale guide here. But maybe the simplest is to scale by the ratio. So if we wanted to scale by length, we'd use by length option and then just scale off that. But in this case, we'll use scale by ratio is 1 in 400 at A3. So we just type in 1 in 400. Click OK. Now with any scaling operation, it's really important that it's right. Otherwise your whole project is going to be out. So if you press and hold down the M key, you can stretch across and you can measure that. So when you're scaling by ratio like this, it should be spot on. Okay, so that's one plan. Now, because we're stitching, we need to actually crop the plan to the stitch edge. So I'll do a crop here and try and get it right on the edge there. So hopefully we can join them right together. So when you're doing the PDF vector extraction process, you want as tiny gap as possible between the contour lines so that they automatically can be joined with the tools. So we click OK, OK again, and then we've got to add the second page after it loads. So that's our first plan in. So now we need to add the second page. So we go Add PDF. And then we just follow the same process, select page 2. Now, second page should load with the same scale as the first one. So you might find that it doesn't actually need scaling, it just needs moving. So this one, but we'll check it anyway. So we use the M key to check this scale, make sure that it's right. You sometimes find 2 pages have different scales in PDF, so it's definitely worth checking. Now I can now use the move tool to just move the plan to a common point. So if we say find the corner here, this corner here is on both plans. So we just, you find sometimes corners of buildings, curbs, that kind of thing. Sometimes there's marked total stations that you can use. So what's key here is that we can see just the edge of that site plan. We need to crop this one so that it's just, there's a small gap between the two. So that's going to be quite tricky. So I'm going to get the line right first, and then I'm going to adjust after I've got the line right by zooming right in. I'm then going to pull this crop, so you can crop it again, and then you can just pull, should be able to pull this line up. So get the sort of match line perfect first, and then you can adjust the outer line. But it's key that for when you're extracting vectors, because we're going to be going through the PDF vector extraction process, that there's a small gap between, like you can see, there is a small gap there. So those vectors should join nicely. I could even move it slightly down, which I can go edit, and I'll maybe move 1 point tiny bit down. I mean, it's really not that necessary, but so that's well stitched there. It is worth, you know, when you're doing PDF vector extraction, to make sure that it's like a kind of nice gap and they're not sort of offset. Spend a bit of time making sure that's perfect. So the next step is to extract the vectors from the PDF. So this is the existing tab. We'll talk about the construction phases later, but when you're in the existing tab, there's two options to define your existing surface. There's a feature surface, if your existing is made up of points, contour lines, or breaks, or there's a triangled surface, if it's been defined in another program, it is already a triangulated, or TIN as it's called, a triangulated surface. So we're going to be using the feature surface here. Now, a feature surface is made up of outlines, contours, break lines, and points. This is called the takeoff editor, and sometimes you'll be tracing, so we can just draw, like for instance in this case I'm going to draw a outline, so you can trace here, and sometimes if you can't do a PDF vector extraction, that's necessary, but what we're going to be trying to do here is actually extract the vectors from the PDF. So what I'll do is I'll click on the contours, I'll click on this button which is add from file, and I'm going to click on all PDFs, so that will try and extract the vectors from both PDFs rather than a page at a time. So go all PDFs. So what you want to be doing here is setting a filter which selects just the contours that you want. In this case, our existing contours. It's done a pretty good job of extracting those. And we've actually picked up some text. Now this is line work as text, and we don't want those. So what we can do is we can go remove short lines, and it should remove the lines that are just like little bits to make up text. So that's a pretty good extraction. If we click simplify, is always worth doing it. Basically, there's 2,169 points representing these contour lines. And if we increase the slider, it'll actually simplify them. We don't necessarily want so many defining the we can get away with a much more simple set of points. If you zoom in, you can see the originals and the simplified versions, so that's worth playing around with. So we click OK. Because this is a PDF and the vectors have been extracted, they don't have any elevations at the moment. So one technique we can use is we can manually set them. So I can just set, say, this one to 1276. Set this one to 1276.5. So that's one technique. Faster technique is to use this set multiple elevations tool. So the way this works is you can select sort of a batch of contour lines. Like I'll select all the way through here. So that one is 1276.5, 1277.5, I believe. Just follow that one around. So that is 1278. So we type in, it starts at 1278. The contour interval is 0.5 and it's ascending. So if we click on continue, it will set all of those contours as a batch. Now it works in terms of going across pages because we left that small gap, and the CAD entity importer was able to join those lines using a join gaps algorithms. Now there is options for joining lines or splitting lines if you need to. Sometimes it's necessary for join ones that haven't connected properly. So it's worth connecting them all up before using that set multiple elevations tool. Otherwise you'd have to do it page by page. But that's worked quite nicely. So I might spend a bit of time setting some of the others, and then we'll go on to triangulate. So now we're ready to triangulate the existing surface. So every surface needs a outline. So we've got a couple of choices. The first choice is to use a extrapolate outline, which is kind of floating and takes its elevations from internal contours and points. So we can trace it around like this. Or we can actually shrink wrap one, so that if you click on this automatic option, it allows you to shrink wrap an outline around the data. So in this case, I think we'll use that one because it's a bit quicker. So when you're ready to triangulate your existing surface, you just click OK, and it should make a surface there like that. So one tip I have is that we can change the ground level shading to something that's a bit easier to see. So I'll change it to ice. Click apply like that. So that's the existing done. Basically, you can hover the mouse around to check your elevations are correct. Another thing that is quite useful is to exaggerate vertically to, you can spot any anomalies, or especially if you're using points and there's some like high points, you can use the vertical exaggeration to check that. So in Cube2Cube, to explain a bit about the construction phases, you have each phase is a comparison between two surfaces, and then we calculate the cut and fill of those two surfaces. So in a situation, sometimes you need actually a comparison between more than two surfaces. For instance, if you imagine a backfill operation, you're calculating from the ground to the excavation as one operation, and then from the excavation to the backfill level in a second operation. So it's actually a calculation between three surfaces. So in that case, we would need three phases. In this one, we've got a topsoil strip phase. So that needs to be its own phase. So basically we're going from existing to the topsoil strip level to the bulk earthworks level. So you've got to kind of think of your project broken down into comparisons of surfaces, and each comparison is a new phase. So that might be backfilling, piling mats, excavation for piling mats might require different phases. Demolition is another good one. In this case, we have a sort of three-phase one. We have the existing surface, then the topsoil strip. So I'm going to rename this one to topsoil strip. And then the final one we're going to be doing is bulk earthworks. So we're going to be calculating to subgrade level earthworks, or as it's sometimes called, formation level. So if you click on topsoil strip, so for a strip operation, we've said already it needs to be its own phase. So what we're going to do is we're going to use a reduce element, which just reduces the topography down a fixed amount. So we could try extracting it from the PDF vectors, but I think in this case it's quicker to just trace your adjustment. So we'll click finish and OK. So the default is 1 meter reduction, so we're going to change that to 400, which is the topsoil strip thickness we want in this case. So the key thing is we're not defining new elements over the top of the strip, because it would actually effectively replace the reduce if we did that. Instead, we're going to create a new phase, so that strip is sort of baked into the model. You can see that edge there where the reduce has been baked in, and so we can calculate to our formation level and adjust to the subgrade in the same phase. So moving on now, we're now on the proposed contours, which are in a similar way defined in the PDF file as contour lines. So we could, if we wanted to rationalize the site sort of into different elements like flat areas or slopes, we could build it up with loads of different what we call geometric primitives. But in this case, where everything's defined as a single set of proposed contours, it's best to use a feature surface. So using the same technique that we did for the existing. So I'll click on the feature surface and then click on contours, click there, and we're going to do the same technique again. We're going to go all PDFs, and we're going to go new filter, and this time we're going to select the proposed contours, and that's come through nicely. There's maybe some error there that we need to correct. So we click finish. So there's some glitch here which has caused this contour to come through not quite right. So I can quickly fix that by just dragging this point across. Click done. So basically we have the same situation here where we have contour lines that aren't set because they're from the PDF. So we're going to use that set multiple elevations tool again. So we just strike through here. We go, okay, there's 1281.5 and it's ascending, it's 0.5. So we click continue and then we click finish. If you like here, it's the same kind of thing. So I mean, set multiple elevations, 128, 0.5, ascending, continue, finish. So I'll just spend a bit of time setting all the elevations in this one. So here's a nice section to demonstrate the multiple elevations tool. So you can actually, we don't have to use a single line, we can actually trace along that whole center line of the road there, and we can set, so we know that the first one is 1291.5. Okay, so now we've set the contour lines using the SME tool manually. We need to set an outline for this surface. Now, previously we used an extrapolate outline around the existing surface. In this case, the proposed has a slightly different setup. This is what's called a match line. So it's a line that matches the ground. So here we're going to probably trace a use ground level line. Now we could extract that from the PDF vectors, but I think in this case it might be a bit tricky. So I'm just going to trace a line around the extents where the proposed matches the ground. So the key thing is to use a ground levels outline, it's called, and that is for that purpose. So you don't have to put in any elevations, it just pins it to the ground. Okay, so now we're ready to calculate the proposed. So we click finish, click OK. And so that is our proposed surface. We've got the proposed contours that we've extracted from the PDF vectors. We could also trace them, and then we've traced a ground match line around the extents of that surface. Now you might notice this road is a bit like a sawtooth around the edge. If you see that, it's usually that brake lines are required to define that edge, to make a better job of defining that edge. And I'll demonstrate by editing that surface again. So we click on the edit button there. And then what we can do is we can trace brake lines. So brake lines are like contour lines. You can see in the site plan they're mapped with these turquoise lines, that sort of road edge. But they can have different elevations along their length. So for instance, if we click on a brake line here, we could type in the levels. So we could type in 1285.5 there, and then we can continue along. You can just leave the input blank if you don't want to type anything, and it'll interpolate it from its neighbors. And then we can click on, say, 1286 here, 1286. But the thing is actually about brake lines is they also, when they cross contour lines, they also have the sort of like capability to just pick up the level from the contour line. So if a brake line crosses a contour line, you don't actually have to type in any values. I just did those first two as a demonstration, so I'll just carry on like this. So I'm going to trace two brake lines, so I can complete that one, and next, and then I'm tracing them here. We could extract them from the PDF vectors, but often you find that you have to trace brake lines because they're not represented in the site plan in a nice way that can be extracted. So we've got two brake lines there. So when we click OK, you should see the effect that that has on the edge of the road here. So typically brake lines are used for defining like kind of hard landscaping, changes like retaining walls, sides of roads, etc. So that's looking quite nice. Now the only problem is we've calculated this bulk earthworks phase at finish level, so we rename this one to finish levels. But what we actually want to calculate is to subgrade or formation level. And there's two processes for doing that, basically. If we're defined this site as different primitive elements, we could sort of adjust those down using the Z offset and just adjust different pieces of the site by that. But for this scenario where we've got everything defined in a single feature surface, we actually have another technique which is known as the reduce method, which involves layering over reduce elements to reduce different areas of the site by different amounts. So like in this case, let's say that we want to have one material here which is asphalt, which is an adjustment of say 350. So we'd just create a reduce element. Now the key thing is that it has to be in the same phase as the finish levels that you've defined. It's a bit difficult to see, so I'm going to just pop that into a different window and turn on that. So I'm going to try and trace around this area, and I'm going to use a couple of punch outs. So I'm going to demonstrate that. So I'm going to click there and I'm going to trace this area here. I'm doing it quite quickly here, but you usually would be spending a bit more time. So there, okay, so we're going to do two punch outs. So if you do an outline within an outline, the program will detect that that's actually a punched out region. So I'll create another outline by clicking there and just trace around this section. Now you don't always have to punch out, because reduce elements by default will actually override each other. So if you wanted to adjust these intersections by a separate amount, you could. So I will actually demonstrate that technique after doing this, but for now I'm just going to demonstrate the sort of punch out area, whereas it can be handy if those areas were not being adjusted at all. So that's my first adjustment, and then I click OK. And so we'll call that adjust for asphalt or something like this. Now that one I'm going to set to 500. So the key things to remember about this reduce method is you've got your absolute elevations here, defining your finish levels, and then you've got reduce. They need to be on the same phase and underneath. Now it's worth setting the side batter to something steep like 1 in 0.01. It just helps with building the models. Sometimes if you set it to vertical, you have some problems in subsequent phases calculating over the top of verticals, so we recommend leaving a slight side batter there. So when you go into 3D now, hopefully you can see that area has been adjusted. It's a bit hard to see in the cut and fill view, but if you switch to the element colors view and change the colors of the elements, it can make it a lot clearer. So I know, just to demonstrate, I'm going to do another reduce for the building pad. So I'll go down here and do another reduce. I'll set that one, I think that one's green. So unadjusted, I'm going to leave on orange. The asphalt adjustment is like a lime green, and this one's a purple. So I'm going to rename it again. So adjust for building. And I'll set that to say 400. And this one to 0.01 again. Now you can see the dynamic in the element colors of the punch outs, how this one contains those punch outs. And so those ones have remained unadjusted at finish levels because they've been punched out. Another technique is you can actually use overriding if you want. So I'll just show you deleting those punch outs. So I'll go in and we'll delete this one and this one, which are the two sort of inner outlines. So that will have an effect of those areas initially being adjusted. But what we can do is we can say if we wanted to adjust those sort of planting areas, you go add another reduce. This will have effect of overriding the other areas. And I go next, and I'm going to do another outline for this section. So, I mean, you can punch out if you want to. It just is sometimes a bit faster. So if you have like a main area and some planting areas, you can do an adjustment of the, you can do main adjustment, and then you can override that with a separate adjustment. Now, the order is very important, so I'll just demonstrate that quickly. Adjust for planting boxes. If we change this to something like pink, you can see that area is a different adjustment. We'll quickly do the 0.01 and adjust that by 200. So you can see that dynamic. Now, why I say the order is important. So the override order is kind of is based on the order of the elements in the list. If I move the planting box above the asphalt, it would actually, the asphalt would eradicate that adjustment. So the element colors view, which you can find down here, is really useful for making sure that you haven't misunderstood which element's overriding which. So you can see here that actually these areas are no longer a different adjustment, they're just being adjusted for asphalt. When you click on it, it just all shows as asphalt, and it's because this one has been, which is in the same space, is basically been overridden by the asphalt adjustment. So we'll move that back down. So it's really important to know how to check your elevations. So the most basic technique is to use point checks, like hold your mouse over different areas. You can see the ground proposed in the cut or fill in that area. So in this case, it should be at subgrade or formation level. Another thing is if you double click on the measurements panel, you can see this cross section. So you can create a cross section across the site, which is a really useful way of understanding the elevations. One tip is if your surface is exaggerated, like in this case, the cross section will also be exaggerated. So that's quite useful to really just understand those elevations. Another one with adjusting to subgrade is you can actually select all the adjustments. So if you click that top one, select that bottom one, you can actually turn them all off temporarily. So you can see the project calculated, adjusted and unadjusted, and that might help you, have a reality check about what the elevations are in both scenarios. So I'll just turn that back on again. So we've covered some of the basics in terms of understanding the cut and fill estimate. Each phase has its own individual cut and fill between those two surfaces. It's not a cumulative total. Another thing to be aware of in this scenario, which can be a tiny bit confusing at first, is these will report a cut and fill in the report. So if we go to File, Create Spreadsheet, you'll see that these items are listed separately, so it's finished levels. So the way that you need to read this is the cut and fill in that area. It's not cut and fill of asphalt, because that's just creating a cavity in some ways. It's just adjusting down. But we break it down. So, okay, what's the cut and fill in that area? What's the cut and fill in the building? Where they intersect, again, the lower one takes precedence. So the finished levels is just reporting the area that remain at finished levels, and then the asphalt is the asphalt area, and then the building pattern and such. It can be useful to break down like that, which is why we do. But it's important to not think that, okay, that's an estimate of the asphalt. It's not, it's just that area which has been adjusted for asphalt. So that's worth paying attention to. You've got other exports you can do for, like, export to CAD or Land XML for use in other programs, machine control and BIM. You can also export the report to Word or PDF, which is really useful to passing through clients or building up with other information. So that's the end of the project. I hope it's been useful. Like I said, there is another version of this video which covers the CAD site plan process, so that's worth watching if you do use CAD. Okay, so thanks for getting this far into the video and watching the whole thing. I hope you learned something today. If you do have any comments or feedback, please post in the comment section below. We're always interested to see what questions you have. And if you do have any ideas for other videos you'd like to see in this series, please let us know also, and we'll try and add them to the list.